All right, hello and welcome to today's last session. My name is Simon Wåhlin, and we're going to talk about how we're moving from the old click-ops style to a more modern and controlled GitOps style using a wonderful tool created by Microsoft called AZOps. So many of our old systems are sorry, better. Good. All right, so many of our old legacy systems are used to living in something not too unlike this thing, a fort or something with a very strict parameter defense. To anything that should get in or out of our fort has to pass the drawbridge, get through the guard in the door here, and once we're inside, we can pretty much rely on the people inside being who they say they are. So a lot of our legacy systems are born and raised inside of these walls, and they aren't really used to be and function outside of these walls. Then suddenly we start to summon islands in the sky. We start to build new infrastructure. We build a small cottage or a house on a piece of floating ground. And suddenly, anyone with an air balloon can come and land in our backyard. So now each system needs to be aware of their surroundings and need to take their own responsibility for their own protection and be able to validate who they're talking to and who's visiting them because they can't rely on this gi- gigantic outer wall. This also means that a lot of our old systems doesn't really fit in this new picture. So one of the things that, or this is one of the things that are solved with something that Microsoft calls the enterprise scale architecture. I'm saying that the enterprise scale architecture is solely for this purpose, but one of the things that it solves is this. So what we do really quick is that we build a structure in Azure, and I represent this by showing the management group structure that we build in Azure. That usually starts with a root management group that we name our company. In this case, Contoso. Below the Contoso management group, we create a few management groups or more generic management groups. We call them platform. And inside platform, we have a place for identity where we can put all our identity related subscriptions. We can put a management group called connectivity where we put all our connectivity connectivity related subscriptions. And we have one piece called management where we put all our automation and management of the platform. And we have another main part of the platform called landing zones. And the landing zones is where we will put all our applications once the platform is set up. We split landing zones usually into at least two subcategories. Subcategories are usually referred to as archetypes. And in my example here, I have two of them. I have corp and I have online. And the last piece we build is a sandbox management group. Using this hierarchy gives us the possibility to put all our platform and central resources over in the platform part of our hierarchy. And we can divide identity, connectivity, and management so we can easily put different set of policies and easily delegate access to different kinds of parts of our organization. So our networking team, for example, if we have a team only working with networking, they can easily have delegated control of our connectivity part, and they can manage all our firewalls and so by building this way, we can keep a lot of our old organization and a lot of our um, old systems and build an on-premises like environment for enterprise. while we still can use a lot of the new cloud functionality. Yeah, there is something wrong with the microphone, isn't it? Try to put it here if we have some. So, and in these archetypes, we usually recommend putting everything that relies on a central networking connection into the core management group. So in the core management group, we put all our systems that have a connection to the internal network. Everything that would be connected to our internal network on premises would go into the core management group. There we can put quite strict policies saying we don't allow any public IPs, we don't allow any public endpoints, we don't allow whatever we don't want to allow on our internal network. And then we have the online archetype where we can build more cloud native stuff. This is where we put all the platform as a service services that aren't integrated to our network. This is where we put all our cloud native stuff. This is where we put everything that don't need to be directly connected to our internal network, that can live on this island in the sky and that has its own protection and is used to validate who is talking to them and so on. So this setup, which I feel represent a lot of the core concepts in cloud option framework and especially in the enterprise scale, I find it very compelling. I really like it because it gives us all the security and like parameter protection that we are used to in an on-premises environment, but it also gives us all the goodness of the cloud, and it gives us the scalability, and we can build new awesome cloud native applications side by side by our migrated legacy systems and so on. So let's look at how this would look in reality, or at least in my demo environment. So I have set up the enterprise scale architecture example that Johan showed earlier today, and that will give us a root management group called, I named mine ESLC for enterprise scale. You probably would name it your company name or something. And we get these management groups, and I have the platform part where I have my connectivity identity management, and in my connectivity and identity, I have one subscription in each, and I put my hub networks in the connectivity part. I put my domain controllers and identity related resources in to my identity subscription. Now, these subscription don't need to be exactly one subscription each. You can have several networking subscriptions, you can have several identity subscriptions if you have different parts of your organization that manages different part of your identity architectural landscape, or different networking and so on. So this is how it looks in the portal, and we saw that earlier today, so it's not super excited. I just wanted to show you how it could look. Problem is, when we do things by hand, we get handmade stuff, and handmade stuff are awesome because they are unique and they are beautiful, but it's really hard to do the exact same thing over and over again. So if I'm going to have a wedding, or I'm going to have a really good party, I want to pay extra to get the handmade cake because it's beautiful. But if I order 100 cakes, they will probably not be identical. And in IT, that is a problem because I want my, well, not cakes, but my IT systems to be identical. Whenever I build a system, I want to make sure that I always get it set up exactly the same way as last time. So instead of beautiful wedding cakes, we want the cookie cutter experience. We want to be able to stamp out cookies that looks exactly the same every time, and we have this exactly the same everywhere. So to make this enterprise scale architecture actually scale, we need to use this cookie cutter, and we need to be able to do the same thing over and over again. And this is where infrastructure as code comes in. So Stefan told told us a lot about bicep and infrastructure as code. I'm not going to go into any of those things, but I'm going to encourage you to try to build stuff as infrastructure as code because it gives us the cookie cutter experience. And if we don't use infrastructure as code, we can see that using the graphical interface, in this case, the Azure Portal. Now, this is kind of an extreme, but you can see that the portal has changed a bit over time. And if I have a document saying that I need this service set up, and you go into the portal and you press the white text stating something over here, and then it looks like this, and the button doesn't even exist anymore, then my whole document is useless and I have to redo everything. Also, there is a problem, and that is the part I've circled here in red. And that is that when we use infrastructure as code, in this case bicep, we can specify an API version, meaning if I deploy my template, it will always deploy using the same API version, and I will get the same resulting set of resources. But whenever I click on something in the portal, even if I click the same button today as I did yesterday, I cannot be 100% certain that the same thing will happen because there could very well have been an update in the API version that will work a little bit different. There might be that I deploy an API manager last week and I got that on the version 1 platform. Next week, I do the exact same steps in the portal and I might get the version 2 platform instead, even though I did the same thing. So using infrastructure as code, we get the same thing every time. It's easy to explain or describe. We don't need to have a lot of text saying click here, do that, do this. And we get a lot more security because there's a lot less room for human error, and we can make sure that it works the same all the time. And we can also easily validate our templates. We can go through a template and say, yes, this template fulfills all our compliance requirements. This is all the settings that we require, and it's a good configuration. Now we can reuse that over and over again. Whoops. So use infrastructure as code because it is important and it is good. It also lets us use developer ways of working. In this case, the pull request works, yeah, using pull request for working. So as an example, we have a developer or technician or anyone creating some change, for instance, changing a template or a configuration file, and opens a pull request. Once that happens, a pipeline will take that code and do a what if deployment. That what if deployment will send our changed code to the ARM API. The ARM API will do a dry run of the deployment and tell us if something is obviously wrong with the template. So we will know if it's likely to if the deployment is likely to succeed. We will also know fairly well what will happen. These resources will be added, these will be removed, and so on. Once we have that what if deployment deployed, we can have another developer or a manager or someone else be an approver. And the approver can look at this what if results and say, yeah, this is what we intend, this is what we want to do. They can sign it to check it, and they can also make sure that all the requirements are met. And then we can approve that pull request. And once it's approved, we can deploy it to our environment. And if we want to, we can also have a stage deploy saying we deploy it to the test environment and then to the stage environment and then to the production environment and so on. So that's the last point why we should use infrastructure as code, because it's really hard to get this kind of process going when we have a document and someone has access in the portal and just clicks create, do this, do this, do this. There is no like approval step, there is no validation, there is no nothing. If you click wrong, it is wrong. But this is all great, but how do we do this? How do we make sure that everything is deployed in a well manner, and it works the same thing works the same way every time. Well, writing it all by yourself is a lot of code and a lot of logic to figure out when someone sends up a file, where should it be deployed, which target scope should we use, and so on. So I'm going to introduce the ACOps toolset or toolkit. And the ACOps toolkit is basically a PowerShell module. Its home is on GitHub in github/azure/ACOps. And ACOps is basically a PowerShell module, but it also has a bunch of GitHub actions and Azure DevOps pipelines that we can use. So in the beginning of the README here, we have a link to the ACOps Accelerator repository. If I go there we go. You can see that this is a repository with some code in it. And this is a template repository that we can use to set up our own ACOps pipeline environment. So I'm going to show you how to do that, and I hopefully will succeed in do it live right away. So here on the ACOps repository, there is a wiki, and in the wiki, let's see if I can zoom out a little bit. Didn't work. All right, so here we have an introduction, prerequisites, services, and we can choose between GitHub Actions and Azure Pipelines. In the introduction, we have some text about how ACOps works and what the tenets about the ACOps is and what it's for. Great information, please read it. Then we have the prerequisites that we need to get started. I have already prepared this because I don't want to handle secrets during my presentation. But what you need to do is to go in and create a service principal. You have the code here. It's basically just copy pasting it. Then we are going to add a role assignment. We can do that in one of two ways. The first way is to assign the owner role at the root scope, the slash. And the second way is to assign a role at a management group. And this is what I've done. So I have assigned my service principal to the management group called ESLC. After that, we need an Azure AD role assignment. The service principal needs to have the directory readers role, so it can resolve users and service principals into GUIDs and so on. So that's basically just code pasting this part of the code, and that is all the prerequisites. If we question, yeah, shoot. So the owner role will be on the management group. I can show you. So this is my management group, and I have assigned the owner role to my here we go. Yeah, I've assigned the owner role to the management group, so it will inherit to everything below the management group. So my whole infrastructure. So if the service principal is responsible for deploying your infrastructure, then it will more or less need the owner role, because it will create RBAC assignments, it will create policy definitions, it will create policy assignments, and so on. So I think it's a good discussion to have what kind of roles we are assigning to what kind of principles. Whether or not it's too high or not assign access for a service principal is maybe not the it's not the fact that it is a service principal that is a problem. It's how you safeguard it. So, for instance, one way of doing it more secure could be to use a managed identity and only deploy with private build agents in, for instance, a scale set. And that way it will be harder to accidentally leak the credentials. But it's absolutely a good thing to think about and be aware of. But in this case, since this purpose of the service principal or managed identity or whatever you're going to use is to build and own the root of your platform, it needs high privileges to do that. And we're going to govern it all with pull request and branch policies and everything. So it's going to be quite high requirements to do something with it. Let's see where we were. Yeah, we had the so we went through the prerequisites, and then we have the services. We can do GitHub Actions, and we can do Azure pipelines. Since I work mostly with Azure pipelines, I'm going to show you that. And also, GitHub Actions is a lot easier. So basically, you can put the files in the right place, and everything will more or less work. Azure DevOps is a bit more involved in configuring. So we're doing the hard part. And the good thing with this is that we have a script here too. So there is some reading and some description. This is the text that describes what we'll do. And then we have a large chunk of code here. I have cut out the first part because this is what we need to change. We need to supply my the URL for my organization in Azure DevOps. We need to give it a project name. So what I want to name my Azure DevOps project. We want to give it a repository name. What I want to name my repository. We also need to supply my tenant ID, a subscription ID, and my ARM client ID and client secret for the service principal I just created. And if you don't want to use client ID and client secret, you can absolutely use a managed identity instead. So then we have this part of the code. I've copied all that into a script right here because it's a little bit easier to read in Visual Studio Code. We're not going to read the code. I'm just gonna quickly go through what it's doing. So the first that will happen is, let's start the code so it can run while I talk. Let me just run the prerequisites first. So I load all my credentials, and then I'm going to start the script here. So the script will first create a new project in Azure DevOps. I have configured to name it AAA_global Azure, so it gets in the top of my list of projects. It's easy to find for a demo. It will set some defaults for the CLI, and then it will create a new repository. And the repository will be imported from this AzOps accelerator that I talked about just recently. That is the template. Let's see if we can get this. There we go. It will import a repository, and then it will create a variable group. And if we have supplied a client secret, it will add a secret value to our credential group. Then it will import 3 pipelines. And these are the core of the AzOps. So we have a push, a pull, and a validate pipeline. The validate pipeline will run every time someone opens a pull request. And that will do the what if deployment and create a comment on a pull request that is the result of the what if deployment. Then we have the pull and push pipelines. So the pull pipeline will run on a schedule. I think it is like every 6 hours or something by default. And it will continuously run and export everything that we have configured to export from the scope where we have pointed it. So in my case, I'm going to export management groups and subscriptions and resource groups. So I'm going to get a nice folder structure where I can put stuff in and deploy it. I can also export, we usually export policies, policy assignments, and role assignments. If you want to, you can even export all your resources and child resources, but we usually don't do that. And then we have the push pipeline, which will trigger every time you complete the pull request and deploy whatever you just have changed in your pull request to Azure. Super handy. Then we add some build validation. So this step will create a build validation policy that will make the validate pipeline run every time we create a pull request. And then we set some branch policies that forces us to only use squash merge. This will do two things. It will, first of all, squash all our pull requests. So whenever I do a pull request, they will all end up as one commit in the main branch. It will also implicitly force us to use pull requests. It will protect the main branch. So this means that no one can change anything in the main branch. We have to create a pull request to change something. Then it's going to add some permissions. So we are going to add the contribute, force push, create branch, contribute to pull request, and bypass policies when completing pull requests actions or rights to the build service. So our pipeline will be able to do these things. And this is for the automated pull to work, because every 6 hours we will export everything in Azure and we will create a pull request with the changes that differs from our Git repository, and then we will automatically merge them into main. It really doesn't make sense to have an approval or validation step there, because we're not really changing anything. We're updating our code from what is in the reality. So that's why we have the bypass policies, and so we can bypass all the approval steps and validations part. Then we have some permissions for the pipelines to use our credentials, and that is it. So hopefully the script has run finished. Awesome. And if we go into our Azure DevOps and refresh the window, there should be a new project creator here called AAA Global Azure. And in this project, zoom out a little bit. In this project, we have a repository. So we can say, see, I have my default repository called the same name as the project. It's empty and doesn't really feel any purpose. We can delete that if we want to. We also have the AzOps repository. And if we go in here, we can see that we have the same files as we saw in the accelerator repository on GitHub. So here the first I do when I get into here is usually to do a cleanup, because I like having things nice and tidy. So I delete the GitHub folder because I'm not going to use the GitHub actions in this project. I have to create a new branch. So I'm going to call it cleanup and do a commit. So now we create a cleanup branch and I can change stuff in this branch. I'm also just going to remove all these files, because even though they are important in the public part of the repository, I don't have any use for them in my local repository. We usually also create a new README that explains what this repository is and how it's used and who owns it and so on. So here we clean up everything. And once I'm done, I create a pull request. I'm just going to call this cleanup. And I'm going to create it. Usually, we have a requirement to have someone approve my pull request. But since I'm alone here, I haven't enabled that, and it isn't enabled by default in the script. So if you want that, you have to enable it yourself. I'll show you in a minute. So I'm just going to approve my own pull request, and I'm going to complete it. And here you can see I have squash commit because all the others are forbidden by policy. Here we go. So that's it. First pull request, we have a cleanup repository. The second part I do is to go into the settings files. So this file is the main configuration of AzOps. And here we can tell AzOps what it should do and how we want it to act. There are two things I usually do in this part. The first thing is there we go. First thing is to change this thing. So we have something called partial management group discovery route. Here I can put the name of my custom management group route, and that means that we will start discovery from that management group. And then we have these skips. So we have skip policy, we have skip resource, we have skip child resource, we have skip resource group, and we have skip role. Here I can set anything that I don't want to have exported from my live environment to true, and that will skip them. So in this case, I'm going to speed things up a little bit. So I'm going to say skip policy. Usually we always export policy, but just to make this a little bit faster, I'm going to skip policy and I'm going to skip roles. And we should only be getting management groups, subscriptions, and resource groups. So I'm going to commit this, say updating settings, create a new branch, because I can't change it in the main since I have a policy on. So let's just call it settings. And I want to create a pull request right away. So now I create a pull request again. I'm going to approve it myself and complete it. Now we are ready to, now we have AzOps configured and everything should hopefully be working. So if we go into settings, we can see here repositories. On my AzOps repository, we have some branches. So we have a main branch, and we should have here we go, a branch policy. So here you can see I have my limit merge types policy that we set in the script. I have my build validation. Every time someone changes something in my root folder, I will run the validation pipeline. And if I want to, I can also set require minimum number of reviewers. So usually we set this and require at least one reviewer. That means every time I want to deploy something to Azure, I create a pull request and one of my teammates has to look at it and approve it. That way, no one will be able to make a change in the environment without someone else approving it. Skip that for now, and let's go to the pipelines. So we have 3 pipeline setups. None of them have been run yet. I'm going to run the push pipeline, the first thing I do. So I'm just going to click run pipeline and accept the default options. This will go through my latest commit, which is my changes to the settings file. It should realize that nothing that is deployable is changed, so it will deploy nothing, and hopefully. And then once the push pipeline is complete, it will automatically trigger a pull pipeline. And the pull pipeline will export everything I have in Azure that I have not skipped and create a folder structure. And I have a PowerPoint slide that explains that. So while that is running, first off, there are a few tenets about the AzOps project that I feel is important. So I have cut out those. First off, is that git commit is the new AC deploy. So the point of AzOps is that instead of using AC deploy, instead of going to the portal and doing something, or instead of deploying a template from my developer or workstation or whatever I work, I can commit my code to Git, and then I don't need to care about it. Someone will approve it, and it will be deployed. Very nice way of working. There is also a part where we should be able to the goal is to be able to deploy templates in all scopes without having to do much work. So the organization for North Star, which was the working name for enterprise scale, if I remember correctly, was that we should be able to create landing zones at scale, and ACOps then will enable us to do this in a quick and a good fashion. And the third category is to operationalize configuration drift and reconciliation by having immutable configuration in Git. So if we use ACOps, we have a very good way to define everything as code, just check it in and let ACOps take care of deploying stuff and validating and so on. So here is a small animation that will describe what will happen when we do something. Here is my repository with my settings file. The first thing that will happen is that we will run a pull pipeline that is hopefully running right now. And that will take all these resources from my custom route that I have defined using my service principal, and it will export all these resources, and it will create a folder structure that looks just the same. Then I will create a pull request and add a storage.json down here. This could be an ARM template or a bicep file. Once that is approved, I will trigger a push pipeline, and the push pipeline will create the deployment, and I will have a new storage account in the same place where I put my file. So there is no code to be written. We don't need to define any logic. We don't need to do anything ourselves. We can just drop a file in the right folder and it will be deployed to the right place. Then I do the same with a key vault, and I get a key vault in the same place. So this is a super simple thing to set up. It's very fast. And if we want to, we can export more or less anything to our Git repository and change it there and deploy it back again. But what we usually do is to try to limit access to the portal, so we can't do anything in the portal. And then we don't need to export the resources because we create resources by putting a file in the right folder, and then the resources will be deployed. And if we want to change something, we go into the file, change the configuration, and it will be deployed again. So let's, before we take questions, go back here. The push pipeline succeeded, and the pull pipeline is running. Let's see how fast this is going. So as you can see, it has a few steps. It will check out the repository. It will check for the latest version of ACOps, and it will do some dependencies, connect to Azure, and initialize. That goes through your environment, and then it will do some status. And if there is anything changed, it will actually add that and commit it and create the pull request. So while we're waiting for that, do we have any questions so far? Awesome. Then awesome. Let's take that. Yeah. So the question is, can the approver be a computer? And that is for this Git flow thing a while back. Yeah. So it can absolutely be a computer. We usually have at least a human, but we often have a computer as well. So having a human here as an approver is just like a code review part. So to make sure that I haven't done something obviously wrong or stupid or something that I'm not supposed to do. You can also have the old change board committee here if you work in the ITIL organization. But you can and probably should also have a computer there. Uh, for instance, you can have automatic gates checking statuses, doing automated tests, or whatever you feel appropriate for your needs. So yes, we can have a computer there instead, or we can have a computer there as well. Let's go all the way back and see. course, this takes forever. Oh, well, so what will happen is that we will get all these files. I think I have another project I ran yesterday evening. So if we go in here, we'll see how it looks once it's done. In this case, we have been running a few pull. You can see I ran one yesterday. I have one 14 hours ago, 8 hours ago, and 2 hours ago. And apparently I have a failed push, which I don't know why it is, but this is how the repository looks. So we can see we now have the root folder, and we have our enterprise scale landing zone, and I have my my management groups. And if I go into online, I have my online subscription, and here I have some kind of resource group. And if I want to, I can create a new file in this resource group. I can call it storage.bicep. Create. Let's see if I can do it in a new, I hope so. Let's see, where's my, and I have a small bicep template here, which just creates a storage account. So I'm just going to try to commit that to a new branch, add storage, and create a pull request, commit, create, and this will trigger a validation. So this will trigger the validate pipeline. Now that won't run until my previous push pipeline is done, because I don't have any concurrency in my demo organization. But this will stand here and wait, and once it's done, it will do a what if deployment, and it will comment back and see if I have an old pull request. I can show you how that looks. I don't hear. All right. So what will happen is that in this pull request here, I will get a comment here by the pipeline with the output of my what if deployment. And once I'm happy with how that looks, I can approve it, and that will trigger a push pipeline, and my storage will be deployed to the resource group representing the folder. And by that, let's go back to questions. Anyone has any new questions? Otherwise, yes. Great question. So the question is, can AzOps export bicep format or just JSON? Today, AzOps only exports JSON files in ARM templates. So whenever we export information from Azure, we get ARM templates. And that is one of the reasons, one of quite many reasons why we choose not to export resources, because if I create a bicep file and deploy that to Azure and then export the resulting resource back into an ARM template, then I have two files representing the same resource, and that can quite quick become confusing. So we're mainly using the push part, and we put bicep files into folders, and we have AzOps deploy them for us. Right. So by that, thank you very much, and I hope I'll see you in the tonight in the event. Thank you.